Okay, in this video we're going to solve the equation. In this equation we have rational exponents, which is different from some of the ones that we handled before. There's two ways we can actually handle rational exponents. One is keeping them as a rational exponent. The other is to turn them into the radical and exponent form. In this example, we're going to keep it as a rational exponent and deal with it there. And at the end, I'll go back through and do the other method as well. So to do this one, just like many of them, since x only occurs one time, we're going to start off by doing reverse order of operations and get rid of anything outside of the parentheses. So I'm going to divide both sides by 2, giving me x plus 5 in parentheses to the 1/2 power is equal to 4. Now, to cancel out a fractional exponent, we want to cancel out that fraction. And the way you cancel out fraction is to multiply by the reciprocal. So the reciprocal of 1/2 is 2/1 as a fraction. And when it comes to exponents, when you raise a power to a power, you multiply the exponents. So to cancel out this exponent of 1/2, we will raise both sides to the 2/1 power. That will allow us to cancel out the exponent because reciprocals are inverses, which cancel out in form 1. And our goal is to have an exponent of 1. So they cancel out, leaving us with just the x plus 5. Since the exponent is now 1, we no longer need the parentheses. And on the other side, we have 4 to the 2/1 power, or in other words, 4 to the 2nd power, which is 16. And it's just a one-step equation from there. Subtract 5, get x equals 11. Don't forget to check answers for extraneous solutions. So 2 times our 1 plus 5. Oh, that's not 1. 11. Forgot my second one there. So 11 plus 5 to the 1/2, is that equal to 8? Well, 11 plus 5 is 16, and 16 to the 1/2 power, in other words, the square root of 16 is 4. So we have 2 times 4 coming down. 2 times 4 is indeed 8. So we are good. 11 is the answer. Okay, in example 2, we're supposed to solve this equation. It's very similar to one of the ones that we did in the previous lesson. You'll notice we have radicals on both sides of the equation, with x occurring more than once. So one of the general methods when this is happening is just to get rid of the radicals first. Now, when we did this in the previous lesson, it was square roots. These are cube roots. So to get rid of a cube root, we are going to instead cube both sides of the equation. In doing so, on the left side, the cube root and the cubing are going to cancel, giving me x minus 5 equals, over here, because we have the 2 on the outside of the radical, we apply exponent properties to cube each individual factor, the 2 and the radical. So 2 to the 3rd times the cube root of 7 minus x to the 3rd. 2 to the 3rd will give us 8, and then the cube root and the cubing will cancel out, leaving us with 7 minus x. Because there are 2 terms underneath the radical, I will need to put the 7 minus x in parentheses. Afterwards, we do have to figure out whether this is linear or quadratic, so we'll distribute, deal with any multiplication that we have. So 8 times 7 is 56. Minus 8x. Since there are no exponents here, we have a linear equation. So we'll move all the x's to one side, subtracting x from both sides, giving us negative 5 equals 56 minus 9x. And then from here, it is a two-step equation. So we will subtract 56 from both sides, giving me negative 61 equals negative 9x. And then divide both sides by negative 9. Do know the double negative cancels out, and I do believe that we cannot reduce this fraction, so it's just going to have to stay 61 over 9. We do have to check our answers, so we want to make sure to go back and check plugging our 61 over 9 in. So we have the cube root of 61 over 9 minus 5. Is that equal to 2 cube roots of 7 minus 61 over 9? So it's not the prettiest one, so I think I'm just going to use the calculator here to save a little bit of time just to double check these. So the cube root, the first side, the cube root, then where is it on Desmos here? There it is. So the cube root of 61 over 9 minus 5, is that the same value as 2 cube roots of 7 minus 61 over 9? Do we have the same value? Yes, we do have the same value. These two expressions are equivalent, which means overall this does check out. And 61 over 9 is our solution. You can also do that by hand, but because of the fraction, I just wanted to save a little bit of time and did it in the calculator. So in this one, we are solving another equation with fractional exponents or rational exponents, as they're called. So we're going to go through the same kind of process. Just like before, since technically we do have more than one x, but they are in the same set of parentheses. So we're just going to get anything outside of that set of parentheses to the other side first, and then we'll deal with finished solving. So to get rid of the 5/2 power here, we will raise both sides to the 2/5 power. Raise both sides to the 2/5 power. Exponents will cancel, leaving me with x squared plus 5x plus 5. And then 1 to any power is going to be 1. Now we just have to solve this. This is a quadratic because of the squaring, so we'll move everything to one side, and then I'll probably try to factor. So we'll subtract 1 from both sides, giving me x squared plus 5x plus 4 equal to 0. We could go through and try to factor this. Most likely it is factorable if it has a solution. So multiplying first and last, we get 4x squared. Combination of factors that will add up to be my middle term is 1 and 4. Since there is no leading coefficient, we can jump straight to the factors of x plus 1 and x plus 4. Zero product property says if we have two factors multiplied together to equal 0, then one of them has to equal 0. So we'll have x equals -1 as one possible answer. And if we set x plus 4 equal to 0, we'll have x equals -4 as another possible answer. We do have to check these answers to make sure they work out right. So if we go back up to our original equation and plug our first answer in, so our -1 squared plus 5 times -1 plus 5 to the 5/2 power. It should be 1 if it's correct. -1 squared is +1. 5 times -1 is -5. Plus 5 is in the parentheses. 5 plus 5, or -5 plus 5 is 0. So we're going to have 1 to the 5/2 power. And 1 to any power is still 1. So first answer, -1, checks out. Second answer is -4. So if we check that out, in parentheses, -4 squared plus 5 times -4 plus 5. 5 over 2 is that 1. So we'll have -20 plus 5, and we'll have a +16. 16 minus 20 plus 5 should be +1. If I did that math correctly. Yep, +1. And +1 to the 5/2. if I can write the right numbers, is again 1. So both answers do work out this time. Make sure to check them. Okay, in this example, we're going to be solving this equation. Now, we already did this example earlier. However, we're going to look at it in the other method. So just going through, we would start off by, for the other method, just changing this fractional exponent into its radical form. Remember, a fractional exponent is the exponent over index. So we'd change it to 2 square roots, with the index being 2, and an exponent of 1, so x plus 5 to the first power. Because it's to the first power, the parentheses in the exponent of 1 aren't needed, so we can simplify it to that. And then just solve it like we would any ordinary radical equation. Divide by 2. Remember, the index is implied to be 2 for the square root, so I don't need to put the 2 there. Equals 4. Get rid of the square root by squaring both sides. Get x plus 5 equals 16. And subtract 5 and get x equals 11. Remember, you should check your answers, but we did check the answer for this one earlier on, so we are going to omit doing that this time since we already know it's correct. Now, this method can always work. It's more just a matter of personal preference. However, this brings about an important reminder. So this equation is actually a very simple equation, but if we were to go and solve this in either method, raising both sides to the 3/2 power to get rid of the exponent, we have to be very careful of something that happens here. You'll notice in the bottom, compared to the other examples, in the bottom we have an even number. That is important. Remember that when you take an even root on both sides, or when you have to do an even root on both sides to solve an equation, that results in having 2 answers, 2 possible answers. So having, whenever you do the fractional exponent, having an even number on the bottom is essentially having an even root, or taking an even root on both sides. So just like when we were to do, if we had x squared equal to 4, that would give us x equals positive 2 and negative 2. We have to take that into account here as well. So if we go through and do this, the exponents cancel out, giving us x equals plus or minus. This, in other words, is the square root of 4 to the 3rd power. Square root of 4 is 2, and 2 to the 3rd power is 8. So both positive and negative 8 would actually solve this equation. So sometimes if you are one to forget about this, sometimes it can be helpful to turn the rational exponent into a radical and exponent separately, because it makes it a little bit easier to see when you need to add this plus minus on to these solutions. So that's the final note.